All right, students. So what I wanted to do today is tell you how to do 3.6 COVID vaccine. So what you can do is you're going to grab a green paper here in class, and this is what the paper looks like. This is what our task today is. And so what we're doing is that we are looking at the COVID vaccine, and we are comparing it to the vaccines that we have seen in class before. And we're going to see how that works by looking at these images here. So these are the images you had seen previously about how vaccines work in the body, right? So you have a vaccine. It has the pathogen inside of it. You inject it into the blood. The pathogen has a protein on its surface called an antigen. And what the immune system does is it sends B cells, which carry antibodies, to send their antibodies toward these antigens to try to see if they are foreign or from your body. And so what happens is, right, like not your antibodies are not always going to connect. Sometimes they don't connect, which means that the B cell will go away, and a new B cell with different antibodies will come to try to eliminate this thing that could get you sick. So it'll send its antibodies. The antibodies will connect. This time, that means now these pathogens are labeled. They are they now are marked so that the macrophage, which is another immune cell, can come by and eat them and envelop them and get rid of that pathogen. So once we have eliminated the pathogen completely, the B cell is going to become what we call a memory B cell. So in the future, if someone sneezes on you or coughs on you and they release this pathogen on you, and that pathogen comes to your body, you have memory B cells that will release these antibodies and attach to these antigens yet once again. The macrophage will come by, eat all the pathogens, get rid of it, and you will be healthy. Okay. Now we're going to look at the COVID vaccine because the COVID vaccine works a little bit differently. So once again, we have the vaccine. However, in this case, the vaccine does not contain a pathogen. This time, the vaccine contains what we call an mRNA. An mRNA. Remember, when we're looking at transcription and translation, we have an mRNA for a protein called the spike protein. So this mRNA is going to be injected into your muscle cells. Instead of into your blood, we're going to inject into your muscle cells. These are what cells look like. When we inject, we're going to inject that mRNA into the cell. The mRNA, as we know, when mRNA is in the body, it goes to the ribosomes, and the ribosome, right, that mRNA is going to go through what's called translation, and it's going to go and create a protein. So once it goes into the ribosome, the mRNA is going to be translated. We're going to add amino acids, and we're going to create a peptide. That peptide will then fold and become what we call the spike protein. That spike protein then, right, is been produced. It's now going to leave the cell, and it's going to go into the blood. And the same process that we did from before continues. So we have a B cell that comes, and this is just to give you some insight into what a B cell does. So the B cell also has to make the antibodies. Guess how the antibodies are made? Well, through transcription and translation, right? It's going to transcribe and translate a gene for antibodies into the antibody protein and create these antibodies. So it's going to try the same process again. It's going to try to eliminate this spike protein, try to connect its antibodies to the spike protein. We see that it doesn't work. A new B cell will come and try. This time, this B cell is going to be successful. It has successfully connected to the spike protein. A macrophage will then come by and eat the spike proteins, get rid of those guys, and take them away. And then that B cell with those antibodies will become a memory B cell. So in the future, if you are exposed to coronavirus, which is a pathogen, right? It's a virus. What we happen to know is that on the surface of the coronavirus, we have a spike protein. That's actually what the antigen is of a spike protein. So these little spikes that we saw before that we produced through translation in our bodies are also the antigens. They're the proteins on the surface of the spike protein of the coronavirus. The spike protein is the antigen. What that means then is that what we can do. So right, once we have now that we have the coronavirus in our bodies, now that we've actually gotten sick with it, right, our memory B cells, even though they've never seen the coronavirus pathogen before, they've seen the spike protein before. And so that means that they can still attack it. They can still send out antibodies to attack the coronavirus pathogen and ask the macrophage to come by and eat these pathogens, eliminate them from your body, and leave. And that is how this vaccine works. So they're very similar, but there are some key differences, right? So first and foremost, what type of vaccine is the COVID vaccine? So this is Pfizer and Moderna are just the names of the brands that sell them. But the type of vaccine, so the COVID vaccine is not inactivated or whatnot. The COVID vaccine instead is what we call an mRNA vaccine. So what I would write here is the COVID vaccine is an mRNA vaccine. Now it's asking you how the COVID vaccine works. So the COVID vaccine rate is very similar. And let's just go quickly through these steps. We're going to summarize this. So first we inject the mRNA for the spike protein into muscle cells. That's the first thing that we're going to do. So first, a nurse or doctor injects the mRNA for the spike protein into the muscle cells. That's the first thing that we did. We injected into the muscle cells. So that mRNA is going to go then to the ribosome. And in the ribosome, right, we know that this process is called translation, and we create a spike protein. So then, and also we can actually use our sequence words. So if we go to our science connection words, so we can use our sequence words from here. So first, next, subsequently, right? We can use these words to help guide us. So first, right, first we have our first, then the next word is next. So let's use the word next. Next, the mRNA or the spike protein is translated into the spike protein in the ribosome. We're in the ribosome is in the cytoplasm. You can add all the details you want, but this is just what the major information is. So once we produce the spike protein goes into the blood, and the same process that we know continues, right? Our body is, once it goes into the blood, our B cells are going to create antibodies to try to eliminate the spike protein. It won't always work, but eventually we're going to get it right. Eventually we're going to find an antibody that will connect to the spike protein. So what we'll say is that our next sequence word is then. So then then B cells create antibodies to try to connect and eliminate the spike protein. Right? Eventually it's successful. So once we've found an antibody that does connect to the spike protein, what we then see, right, is the same process as before. Macrophages come in, they eat up the spike protein, and then we can go. So we have after macrophages eliminate or eat. Let's eat the spike protein that have been labeled by antibodies. So we've now gotten rid of that. So in the future, when we are sick, then subsequently. So after that, right? Subsequently, if we are exposed, or subsequently, rather, this B cell becomes a memory B cell. The B cell becomes a memory B cell. And then finally, our body can eliminate the coronavirus pathogen because its antigen is the spike protein. Right? Our body already knows how to get rid of things that have the spike protein. So it's all set. It's all good to go, right? When you're exposed to the coronavirus, which is the pathogen, right? The coronavirus has this spike protein, and our body already knows how to get rid of the spike protein. It did it in the few previous slides. Great. And so that's how it works. So how is the COVID vaccine similar to traditional vaccines? Well, right, if we looked at both processes are very similar in the sense that, right, in both cases, what we're doing is what are we creating here at the end? Well, at the end of the day, what we're really happy about having is, right, we have these memory B cells and we have antibodies. That's what we really need. That's what the purpose of this is right, to be able to eliminate pathogens and to be able to eliminate something that might make you sick. So also we can use these words to talk about similarities, right? So similarly, likewise, to, also, both. So I can write here, so both the COVID vaccine and traditional vaccines create memory B cells with antibodies to eliminate specific pathogens, viruses, or bacteria. That's really what the similarity is between them. There are other details that you can add, but really we can stick with this. Let's see. So then what else can we say? So what are the differences though? So for differences, right, we can use any of these words. Let's use while. Let's use the word while. So what do we know about, so right, in the traditional in the COVID vaccine, right, there is no pathogen, right? We did not give the body a pathogen in the COVID vaccine. There's no pathogen that we're injecting into the body. We are injecting an mRNA molecule, mRNA that's going to create the spike protein. However, in a general vaccine, we are injecting a pathogen. It's just dead or it's very weakened. So that's the big difference. I use the word however, so let's just use however. Let's go for that. So the traditional vaccines inject a pathogen to teach the body how to eliminate the pathogen in the future. However, the COVID vaccine injects an mRNA for the spike protein to create the spike protein. So in this case, we are not injecting a pathogen. There's no risk of this pathogen going and getting you sick or there's no risk of that when you get it, when you're vaccinated, because of the fact that there's no pathogen in there actually. So the COVID vaccine injects an mRNA for the spike protein to create a spike protein. To create the spike protein, the immune system, all right, this spike protein is the antigen for the coronavirus. Right. So in this case, this is just like COVID. There's no pathogen in this case, no pathogen system. Okay, there we go. All right, I hope that's useful for you students. I'll see you soon.